Alright, so in this video I'm going to try to do some fuzzy matching using Google Colab and some data from Google Sheets. So here I have some locations for companies, and there is about 500 of them here. And then for those companies, and not all of them are going to be in the list, but we have this other spreadsheet for tickers, and you can see how we have the stock symbol here. So I'm trying to match the companies, but company names aren't exactly typed the same way. See, there is Walmart, and there is like Walmart Stores Inc. with a dash, and we have ExxonMobil, and then we have this corporation next to it. So a lot of them are going to be the same companies, not all of them. I'm trying to match as much as possible, but our data is inconsistent, so we cannot do VLOOKUP or something like that, or a regular join. So what I'm going to try to use here is this Fuzzy Pandas library, which is a Python library. And since we're going to be using Python, I'll be using Google Colab to get this done. So let's create a new notebook. Now, the first thing we need to do before anything else, just make sure we connect to the spreadsheet and get the data. So let's just copy this spreadsheet link. So I'm going to go to this, and I'm going to go to this code snippets, and let's try to find Google Sheets imports. I'm going to go ahead and run this install here. For gspread, that updated that. We're good. I'm going to clear this so it doesn't get on the way. Now, this is where this is all going to start. So the first thing is going to be to basically just import all the libraries. I'm going to do another code block and move this here. And let's just do this import pandas over here. Now, I'm also going to need this Fuzzy Pandas library, and that we also need to install. So for that reason, I'll go right here and add another code. Now, I have to run that pip install, and the way we run those here, we start with an exclamation and then the pip install command that I got from the library page. So pip install Fuzzy Pandas with an exclamation. If I run this, if that works, that should basically install this library. So it took some time. It says you must restart to use the newly installed version. Let's go ahead and do that restart. So that should be restarted now. I'm going to clear this output because I don't want to look at it. And here we need to also import that Fuzzy Pandas that we just installed. Let's see if there is some documentation here. We already have pandas, so we don't need to import that. So just this should be good enough. So I'm going to go here and add that import. So far, that should be all the imports I need. We'll see if we need more. So I'm going to run this. That should import all those libraries, and see, because we're using gspread, it's going to ask for permissions. So I'm going to click on this, go get the verification code. Copy it, go back here and paste. And enter. And that should get us all connected. So now let's try to make sure we open the spreadsheet we need. So copy this, go back to this, paste the spreadsheet, get the ID out of this. And this was open by ID, if I'm not mistaken. If I am, we'll have to, actually it was probably key. If not, we'll look into gspread documentation. I do have a video covering connecting to Google Sheets and all of this, if you want to watch that for more information here. I'm going to call this SS for our spreadsheet. So now in our spreadsheet, we're going to have to open the worksheet. And there's going to be a couple of those. worksheets. So one of them is going to be this location. The other one is going to be this tickers. So let's go ahead and take care of that. So that should match the name of our worksheet here. Actually, it's location, not locations. And then from that worksheet, we're going to get the data into rows. And then using those rows, we're going to make a data frame. Let's give this data frame a name. And we're going to basically create it from the rows minus the first row. And then we also going to do columns. And that would be the first row from our array. And hopefully at that point we'll have this df locations. Now I want to separate this from the spreadsheet part. So I'm going to cut this out of here. I'm going to run this and create another code block and run this one. Now let's make sure that worked. So if this was okay, this df locations now would be, see that data from the spreadsheet, company, address, city, state. And basically I need to, let's clear this. I need to do the same for the other tab we're working with. And that would be this one, tickers. So that's going to be this. And then we'll rename the data frame. The rest should be fine. So I'm going to run this. Let's just again confirm that I'm going to close this, make sure this worked. Seems like it did. So now that we have this data frames, one is this one, the other one is this one. This is the smaller one. This is the 500 record one. So I'm going to be joining to that to basically try to find tickers and bring them over here. For that, we have to use the fuzzy match. So let's go check their library. See, they read the data frames, df1, df2, which we already did. And then they do the matching, which is this. So let's try to copy that. We will have to at some point go look at their docs, unless this is all the docs they have. I'm just going to do this. I don't need the other one. So now the first one is locations. So I'm just going to replace them with this data frames I've made. So location is the first one. This one is the second one. So the column we're joining them on, see there's left on and right on. So I'm going to have to look and see what the columns are called. This one is called company and this one is called name. So those are going to be our left and right on columns. Ignore case true, keep match. For now, I guess that's fine. So I just want to see how good it's able to match this. Now, I would think there are more options here other than this, but for now, let's just try to get the results. So here, I'm just going to say results. Actually, that's a data frame probably. So let's do df results. And we're not going to print that. What I'll do, I'll just run this to see if I get any errors. So no errors. And let's try to look into these df results to see if it was able to find any matches for the time being. So it seems like it was. See, Johnson & Johnson. Well, these are the ones that are exactly the same, but that's all it has. So it has 6 records. So it seems like right now it's just giving us exact matches. It's just not case sensitive. Now let's look into their docs and see what else we have to change. I'm going to move this one over here. See, there's left, right. That's pretty much what I did. The data frames, left on, right on. The method. See, the default is exact. So we want to use one of the other methods. See, there are these different methods we can use. So this is a pretty popular method. I'm not a big fan of it, but you know, we can use that. There's also this one, and there is a threshold. See, default is 0.6. So first of all, let's change the method. And let's try this one. And I'm going to rerun this and check the results. Now that's taking longer time. That makes more sense. Now we're doing more sophisticated matching. Let's look into this to see what happens. So now we were able to find these two. That's correct. That's actually correct too. This is definitely not correct. This is correct. So you can see some of them are correct, some of them are incorrect. And this is the challenges you're going to have with fuzzy matching, right? So now we can basically play around with threshold. And I think default, see, it says 0.6. Now, if we wanted to do less loose match, we can do 0.8 or something and try this out. And then we need to rerun the results to see what it looks like. So that seems a little better. But it was able to find only 26 matching results. And we had about 500 lists, so that's not a very good matching. Now you'll also see, like, for example, this appears twice. And that usually means that company probably has more than one match in one of the lists. So if I go check this out, like in this locations list, let's try to see how many we have. See, there's one. And, well, the second one is in the second column, so that doesn't count. So there's one in this list. And there's the second. Let's see what's going on here. See, there's one. Now let's see if there's another one. See, there's two. So there are two matches for this company. Apparently, there is one stock. See, this one. And there is another one, which is this. So that's why we have two. So that makes sense. What's not good is that we're not matching enough companies. So what we need to do to match more companies is to make a more loose match. Or we can use a different method of matching. So if we make it more loose, then it's going to match more companies. So if we make this like 0. Let's say 65. So this was like 26. Let's see what it is now. So now we have 157. But we also have all this stuff that's not matching very well. So the problem with all of these fuzzy matches is that most of these algorithms, not all of them, but most of them, are basically doing distance measurement. And to give you a very basic example of that and why these are really flawed in most cases. So let's say we have something like AT&T Corporation. And then we have another one that's ABC Corporation. So a very basic example of this approach would be, let's see how much modifications we have to do to one of these to get to the other one. So if I wanted to make this AT&T Corporation to this ABC Corporation, I would have to, well, the A's are the same, so no change is necessary there. Instead of this T, I'm going to have to replace it with B, so that's one change. Instead of this ampersand, I have to replace it with a C, so that's two changes. And then I have to remove this T, which is extra here, to get to be the same thing. So I have to make three changes to get there. Now, the problem with this approach is that if you had this as one of the other options, well, if you remember from here through here, we have to do 3 steps to get there. Now, how many steps do we have to get from here through here? See, this first part is the same. And then we have 1, 2, 3, 4, 5, 6, 7 characters we have to remove or add, depending on from which one you go, to get to the same thing. Which means if we measure the distance, it's more from here to here compared from here to here. And that's where we get the flows with this sort of systems. So what we could do, or the best approach we could do if we're still trying to do this sort of fuzzy matching with distance matching, is to try to normalize our data as much as we can before we try to do the matching with a fuzzy match. So what I'm going to try to do, I'm going to try to get to this list of companies, whatever we have here or here. And I'll probably use this one as an example of cleanup, but we'll apply it to both of them anyways. And I'll try to go through this list and try to clean this up a little bit before I try to do the matching. So for example, I'll try to remove things like corporation, company, PLC, Inc., and all this sort of things out of here, and including all of this other characters like the commas, periods, and all that stuff basically, before I try to do the matching. And that way I have, I guess, more likelihood that I'm gonna get more matches and more accurate matches. And this is something that depends on your case, right? So sometimes you could also need to reorder the words. So if you have like people's names, and sometimes it says John Doe and then it says Doe John, last name first, you may want to also reorder them alphabetically before you do the matching. So let's try to clean this up as much as possible, and we're gonna do that here. So the one we're trying to clean up right now is this tickers data frame, and we'll get back to this later after we hopefully do some cleanup. So I'm gonna take this df tickers, and in here we're trying to clean up this name column. So to get to just that column, we can do this, and that's the name of the column right here. And that just gets us what's called series in Pandas. So if I run this, you'll see it's just going to give me that column out of here. Now I want to do some basically search and replace here. And I'm going to do this using regular expression. So we should be able to do that by using this str on this column. And that basically should give us access to string methods. Now, we need to see what the methods are called. So I'm going to go ahead and open the documentation for pandas. All right, so this is series we're talking about right now. It's one of the columns. Let's try to find the str. I'm going to actually search in here. That would be probably easier. So there's replace. Replace each occurrence, pattern, regular expression. So we probably need to get regular expression imported here to be able to use this. So I'm going to go back to our thing here. So we're going to use replace. Here we need to provide two things, the pattern and the replacement. And the pattern I want to be a regular expression. Let's just go to our import and import RE, which is regular expression. And I ran that line because I'm going to need that imported. Now I'm going to go here and hopefully now we should have access to it. Now I'm just going to try to do something without actually using that package to see if it works. So let's say I'm trying to replace anything that's not a letter. So one thing I want to do before I do any replacements or anything, let's just make it all lowercase. So I'm going to get back to this in a second. So I'm going to do, is it lower or too lower? Let's try lower and see what happens. Yeah, lower. That should take care of it. So see, now it's all lowercase. Now I want to see if I can chain it like this, or should I have another str to be able to chain the next one? Yeah, so we should have another one. Okay, so we're going to take the first one. That's going to be lowercase. We don't want to make it uppercase again. Now I want to replace all the characters that are not letters. So what I'm going to do, I'm just going to do a regular expression here. I'm going to say if it's not basically between A through Z, so if it's not that, then we want to replace it by, well, nothing. Let's just run this and see what it looks like. So that actually worked. I didn't have to do anything with the regular expression there for now at least. Now, the issue here is that I also replaced all the spaces. I also don't want to replace spaces, so I'm going to add the space as one of the characters we don't want. Now, if you don't already know about regular expressions, well, first of all, shame on you for not watching my regular expression videos. I'm kidding, of course, but I do have regular expression videos. I will link to those with Google Sheets regular expression functions if you want to watch those to learn more about this. But see, I removed the space as one of the characters I wanted to replace. Now we can see we got all of this. After I replaced all of those special characters, then I want to do another replace for this. And this time I want to get rid of things like Inc., PLC, corporation, company. So we need to get a good list of those. Now I'm going to replace it, and here we have to create a regular expression for that. I probably want to do a word boundary around this. Now the reason I'm doing this, B's, well, let me actually not do those for now, and then I'll get back to that. So let me try to do the list here. So I'm going to do company, corporation, and the way I'm going to list those is by separating them with a pipe, which basically means or in regular expression. One thing to remember when you're doing this, so if you're going to be replacing corp and corporation, assuming there's going to be two different options there, then you want to make sure you always have the longer one first before you get the shorter one, because it's going to replace the first one it finds. So if it finds corp, then it's going to replace like this much, and then this is going to be left. That's why I'm always going to start with a longer one, and then I'm going to go to the shorter one. And I assume there's going to be like Inc. and Incorporated. So we're going to have to look at our data and see what happens as we keep doing this. But for now, I'm just going to add a few. I'm not sure what SA is. Is that a type of company too, probably? So for now, let's actually run this much. I do want to be able to see more results, so I'm going to do .head. So I'm going to do 50 here. That should hopefully display more for the time being. So now let's see what else we got. So I got this D. I'm not sure what that is. Let's just go look at our data frame for a second here without the changes. And by the way, Control-Enter, Command-Enter should run this without having to click here. Let's try to find the thing that I was just looking at. Oh, it was this in parentheses. Are there more of those? Yeah. We probably want to get rid of those. Well, it's going to be all lowercase, so I'm going to do lowercase, but the problem is it's in parentheses. And if I do parentheses, they have a special meaning in regular expression. So we're going to have to escape those parentheses with this, probably, for this to work. So let's try to rerun this to see if that takes care of this. Looks like it didn't. Oh, that's probably because we are doing this after the fact that we removed all the special characters. So there are no parentheses. So maybe we should just do this then. And this is where it's going to get to the thing that I'm a little worried about, is that, see, if there is something in the middle of the word, I'm not sure if I'm going to be able to find an example. So we don't want to accidentally remove if it ends up being like in the middle here. So for that reason, I can't find a good example here, but I'm pretty sure if we go through the data, we'll find something. So I'm going to do this word boundaries, this B's. That means that this has to be a separate word by itself, like all these things we're doing here in the list, not a piece of string in the middle. And I'm going to group all of these together in parentheses like this. So let's run this. So that didn't like this. And I think what's happening is that this is being treated as an escape in Python. So let's try to do this R character in front of this, and that should basically just not do anything in Python land and just do it in regular expression. Yep, there it is. I am going to do it for this one too, just in case. Okay, so that's good. Now let's take a look at our results to see what else we have to clean up here. See, there's this CO, there's this SA, SPA. Let's add a couple of those. So we're never going to get it perfect, but we want to see the best we can do. AG. I don't know if we want to do groups too or not. But let's also look at tail. Let's look at bottom 50. See what it looks like. So head is going to give you the first 50, and this is giving us the bottom 50. I have a feeling like this group we should remove too, but I'm going to keep it for now. So what am I going to do with this? I'm going to remove that tail. So this much with all these replacements right now, it's basically taking this data and basically transforming all of that. One other thing I want to do probably before I finish this is do another strip to remove all the extra spaces before and after. So another .str and then strip. That's like trim, if you're familiar with the spreadsheet trim that removes spaces before and after. For now, I'm just going to leave it like this. So as a matter of fact, what I'm going to do, because this is something I'm going to need to reuse, I'm going to convert this whole thing to a function so we can reuse this. So I'm going to cut that whole thing and create a Python function. And what we're going to pass to it is series. And I'm going to go to the next line, tab it in, so it belongs to this function. And here, instead of doing this, I'm going to do series, which is this. That's being passed to this. And then it's going to do all these changes. So we're going to return the results like this. So what this is going to allow me to do is that anytime I want to apply this to a column, I can just take this, and then instead of this series, I'm going to do that df tickets, and then the name of the column, which I believe was name. And if I run this, that should basically do all these things that I just had. But this should allow me to run this on a different data frame as well if I wanted to also do these changes on a different column someplace else, which is what I'm going to do with that other data too. So right now I'm working with this, but I'm going to do the same transformation with this locations companies. I'm basically going to take this function with all the changes I just did, which I'm sure we can improve more if we just look into this more and find more options here. We need to search and replace. But for now, that's good enough. So I want to add this as an extra column to the columns that we already have. So the columns we already have right now are these two columns, the name and the stock. Now I'm going to also add this third column coming from this to this data frame. And the way I can do that, I can take this data frame and add a new column on it like this and name that column, whatever I want this to be. And then I'm going to make it equal to the result of this. So if I run that, see, no errors. Now I'm going to move this down. And here, let's clean this up too. I'm just going to look into that same df tickers now so you can see what happened to it. See, we just have now an extra column in this data frame. Now, I want to add that extra column the same way to that other data frame for this locations with this companies. I want to have another one of those clean columns, which is going to be pretty much very similar to doing this. I'm basically just going to copy this line, paste it, and only instead of this tickers, we're going to have df locations. or location, whatever it was called. And then we're going to pass it the column from that locations that's called company. So just like this. And the function is still going to be the same. It's going to do all the same things. So I'm just going to run this. And then let's just try to look into this df locations. Now it should also have an extra column there. CO clean, which is this. So now that I have this modified data frame with this cleaned up column, which we, again, like I said, we can spend more time cleaning it up, making it better. But now we are going to do this. I'm going to move this one down. This fuzzy match. So after I made those changes with these two data frames, now let's try to do that fuzzy match again. But there's one thing here though. The column name is different now. This one is called CO clean. This one is CO clean. I'm going to use that new column to do the matching. So let's see if we get more matches now. So that ran. I'm going to move this one down and try to look into this DF results to see what it looks like. I'm curious what that is. Is there a company like that? Apparently there is. I don't think we can do much about that one. See, that one is correct. This one is not so much. So we can do this a little more strict. How many matches was it? It found 1,000 rows. So it basically doubled a lot of them. Let's try to make this a little more strict. 0.7. See what it looks like. So 666. So again, I can make it more strict. 0.8. 350. But now it seems like we're getting a lot better results. Let's look into the first 50 and see what it looks like. That's not good. There is never going to be 100% accuracy when you do this. We're trying to get as good as we can. And so far, this is actually not looking bad at all. Yeah, I'm not unhappy with these results for sure. We were able to find how many it said? Let's look into this data frame one more time. So 350 out of 500. Now again, we can make this a little more loose, a little less loose. We can also try a different matching option. If you remember, where was their docs? Here. They have this. This is the method I think we're on. So let's try this one. That was not a match before. So 1,341. Let's try to make this one more strict. Let's see what happens. I think I like it better. So 0.9. Again, you can play around with this. We got 388 rows and some of them are duplicates. But overall, this is not bad. 0.85. Let's try this. 675. One thing you could do if you wanted to see the full thing all together. Right now, see it says keep match. I assume if we remove this line and run this, we will be able to see all the stuff joined together. See, now we're joining on this columns right here, which is the cleaned up column we have. But this is the actual original, like Walmart Stores Inc. And some of this, as you can see, are not correct. But that's how it's going to be. So what I would do usually at this point, because it's never going to be 100% accurate with just doing this, we should be able to just grab the columns we need. So to do that, we're going to do this and then do another array. And now we should be able to list the columns we want to keep, like company and the name. That's really all we need, but maybe let's do this one too. All right, so that's going to be what I need. I'm going to basically take this and let's save it into a data frame. So now let's try to write it back to our spreadsheet. And I'll just create a new tab here. And to write to that, we're gonna use the SS variable we imported here, see? And we're gonna get the worksheet. Let's just copy one of these lines. And to that worksheet, we need to basically write array of arrays created from this. So let's create that array of arrays. So I'm gonna take this. So we're gonna do 2 numpy and then 2 list, I think. Let's try this to make sure it works. It appears that way. This, if I remember correctly, shouldn't include the name of the columns. So we're gonna add those names of the columns in front of this. So the names of columns we're gonna get from that same data frame. Well, let's keep this line as is, I guess, and I'm gonna combine those lines in a second. So here, if I do columns, then 2 list, that should give me a list of column names. There we go. So now I'm gonna just make it all combined here by doing a list and putting this in there and adding this other list to it. I'm gonna give this a name, AOA for array of arrays. So now that AOA should be that array of arrays that includes column names on top. See? So now we're gonna take that and write it to our spreadsheet. So we have this worksheet, and on that we should have this update method. And see, we need to provide the range we're writing to. So I'm just gonna give it A1 as the starting point, and then values. I believe that was just sending this. So let's try to run this to see what happens. So it seems like it says it was able to write all of these cells. 676 rows. Let's go take a look. Now at this point, if we want to make this more accurate, we need to do a little manual work and go through this and make sure we delete inaccurate matches. And you can make it more loose so it can get more matches. You basically need to find what the sweet spot with your data is and just go with that. All right, so I went through the list, and after cleaning it up, we got about 360 matches out of the 500 here. We're probably a little more there, but that's what I was able to find. So we have a mapping table, and there are gonna be a few duplicates here and there that I left, but overall we got pretty close to this number. So now we can basically do the match using this middle table. So what I could do here, I could basically do a VLOOKUP using this company name. And I would go to this matching list and get that second column, which is basically company names from the other worksheet. At least matching company names. So if I drag this down, see some of them match, some of them are NAs. Now I can now do another lookup doing this value and go to this and now get the matching stock from the second column using a regular VLOOKUP at this point. So that gets us the results. It's not perfect, but like I said, it would never be. So there it is. We found some matches and some that don't match. I can tell you that's still a lot better than manually going through every single one of them. Some things probably could be done better. A little more cleanup in the beginning with the data would probably get better results. But overall, hopefully that gives you some idea of what type of things you could do. And this is something that will work better or worse depending on what your initial data is like. And that was fuzzy match with Fuzzy Pandas library. Thanks for watching. Please subscribe, and I'll see you in the next one.